Hi students, this is the last part of chapter 2 and this is about naming, sometimes called nomenclature. And this is going to be important because this is how we're going to have the conversation. We can't just be randomly coming up with names and unsure of what we're talking about. So the whole part about understanding the difference between covalent and ionic compounds is going to come into play. You need to know the difference because there are different rules for naming covalent and ionic compounds. Let's get started. Naming compounds is basically going through between names and chemical formulas, such as carbon dioxide and the chemical formula CO2. The chemical formula consists of elements, and the subscripts represent how many of those atoms of those elements are present. So let's just take a stab at this. Just intuitively, you look at this formula. I have a P, a Cl, and a subscript 5. How would you name this? Just take a stab. Say it out loud. Maybe phosphorus, 5 chlorines. I mean, you have to have some way to note that there's 5 in this case, right? What do? We use prefixes. The reason is you have to know how many chlorines there are because other compounds like PCl3 exist. So you can't just say phosphorus chlorine or chloride. So to specify, we use Greek prefixes like di, tri, tetra, penta. So this compound is phosphorus pentachloride. So in covalent compounds, we need to use these prefixes to specify numbers. What about Ca with Br2? What would you say there? Calcium is a metal, bromine's a nonmetal, so you form an ionic compound. What do you know about those? Calcium has to be what charge? A 2+. Bromine's a 1-. So right there, we're going to find that you don't need to specify the number. For ions with a fixed charge, like calcium will always form 2+, you don't specify the bromines because you know you have 2. If bromine is a 1-, I have to have 2 Br- to balance out the 2+ of the Ca2+. So the answer is actually just straight up calcium bromide. The only time you need to specify some sort of number here is when you're unsure about the charge of the metal. And so that's only when you're dealing with transition metals. And in that case, you specify the actual charge, not the number of atoms. Let's practice a couple. Covalent compounds, that's when you have 2 nonmetals. You're going to name it by the nonmetal plus the root of the other guy, the other nonmetal, and end it with IDE. How do you know which guy comes first? The least electronegative. So just to let you know, the most electronegative element is fluorine. So anything to the left or below another guy is less electronegative. So if I have PCl3, phosphorus is here, chlorine is here. Phosphorus is to the left, so I name it first, phosphorus. And then I have 3 chlorines, so tri, and then chloride, phosphorus trichloride. Here are the other prefixes, mono, di, tri, tetra, penta, hexa. So these are usually easy to remember. Tetra for, think of Tetris, that game with the 4 blocks. Hepta's hard. For some reason, that's hard for people. Remember, that's for 7. Octa, octopus has 8 tentacles. Nana, 9. Think of nano, 10 to the 9, or 10 to the -9, however you like to think about it. And deca is 10. So let's do another one, SiBr4. If you look on the periodic table, silicon is less electronegative than bromine. And so silicon comes first, and then you specify the 4 bromines, silicon tetrabromide. There are a couple little tedious rules, which is not that important, but if you end with an A or an O and you start with a vowel next, you drop that last A or O. So I'm going to start here. The final A or O of a prefix is dropped if it's followed by a vowel. And the other thing is mono is never used for the first element. So if I have CO, I do only have one carbon, but I'm just going to say carbon. And I have one O, so I say carbon monoxide. But notice because I had originally monoxide, I'm not going to say carbon monoxide. So it's carbon monoxide, not monocarbon monoxide. Okay. You guys practice these. Pause it and write your answers down. I came up with dinitrogen tetroxide, drop the A, boron trifluoride. That's it for covalent compounds. So those are when you have two nonmetals. Now let's do the ionic. Metal and nonmetal plus IDE. So we did calcium bromide. I explained that already. Anything with a fixed charge. These ones in yellow, group 1, 2, and then these 3 in the staircase for transitions. These ones will always have a fixed charge, so you never need to specify any number of charge or number of atoms ever. So the other thing you need to know to do compounds for naming ionic compounds is that they're neutral overall. So the total positive charge equals the total negative. So if I have magnesium iodide, say I gave you the name and you have to write the formula. You know you have a magnesium. Magnesium, let's back up, and you can see magnesium is here. It's a group 2. So it's a 2+. And I need to pair it with I-. But I have to have the 2+ be balanced with the total 2- charge. The only way I can do that is have 2 I's. So I write MgI2 for magnesium iodide. If I wrote magnesium oxide and it asked you to write the formula, you would write Mg2+ first and know that you pair with the O2-. Those are already balanced with charges. So then you already have MgO. You don't need to do anything else. Okay, for those guys, those transition metals that have variable charge, here's an example: copper plus, copper 2+, iron 2+, iron 3+. You have to specify the charge using Roman numerals. So be very careful. The Roman numeral is for the charge. Has nothing to do with atoms. You never specify number of atoms, just charges. So copper 1, 2, or iron 2 or 3. You're going to use Roman numerals to indicate the charge in these problems. So if I have CuBr2, you have to figure it out by the formula. You could have copper 1+ or 2+. So you need to look at what is it paired with. Oh, it's paired with 2 Brs. If it's paired with 2 Br minuses, overall that's a 2- here. So to balance out the 2- and add up to 0, the copper must be a copper 2+. So I write copper, Roman numeral 2 to match the charge. Fe2O3. So you don't know what iron is. It could be 2+ or 3+. Oh, you do know. It's a group 6, so it has to be a 2-. So here you have to do a little calculating. You have a O3, but it's a 2-. So you have 3 O2-. 3 times 2 is 6. So you have a total 6- charge. That means this whole thing must be 6+. Since I had 2, each one must be 3+. So you have iron 3. The other thing you can do is what's called the crossing method. You could have written 2- for the O, and you could see 2 and 2 go across here and match, and that means 3 and 3 cross here, and you have iron 3+. Okay, let's practice here. Palladium 2 chloride. What's your formula? And just remember, the positive charges must balance and equal the negative charges to add to 0. And then pause and do the next one as well. I get PdCl2 because each chlorine is a 1-, and this 2 tells me I have a 2+ for palladium. That means I had to put 2 CLs. This case, manganese 2, that means I had a manganese and I messed up. I wrote magnesium, and that's a very bad mistake. I'm not sure what happened there. It should be Mn. So I apologize. This is Mn. And this should balance out the nitride, but nitride is an N3 minus. So to make this work, you need Mn3, N2. This is easier done when it's not easy to just simply double or triple one of the guys. Use the crossing method. So Mn2 plus and N3 minus, this 3 will go down here and this 2 will go down here. Because then when you multiply, you have an overall 6 plus and an overall 6 minus. Okay, what about polyatomics? It works the same way, you just use the full name for the polyatomic. So if I had NiOH taken 2 times, so notice now I use parentheses. Only when you need to use polyatomics more than once, you put parentheses around the whole thing. This is hydroxide, that means I have 2 hydroxides. Each hydroxide is a 1 minus. So since I had 2 hydroxides, I have a total of 2 minus. That means my nickel must have been 2 plus. So I write nickel, Roman numeral 2, hydroxide. Okay, here's a summary for you guys to look at. And that's where I'm not going to end. I'm going to do a concept check. So you guys, if you want, review that summary, but let's do a couple problems. Pause this and answer these questions and I'll go over it. The first one is, what is the formula of tin 4 chloride? So tin 4 means you have a 4 plus. To balance it out with Cl minus, you need 4 Cl. So it's SnCl4. Aluminum sulfide. The biggest tip I can give you is write out the ions, take your time, and then figure it out. Al3 plus, that's a fixed charge. Sulfide, the 2 minus. It's not easy to just double or triple one, so do the crossing method. The 2 goes down here, and the 3 for aluminum goes as a subscript for sulfur. Al2, S3. SO3 is covalently bonded because we have 2 nonmetals. So you use the prefixes. Sulfur trioxide. Ammonium carbonate, write it out, NH4 plus, and carbonate is CO3 2 minus. So to balance out plus with 2 minus, I need 2 ammoniums. And since it's a polyatomic, if it was just 1 ammonium, you don't need parentheses. But since there are 2, put parentheses around the whole thing. That means you have twice as many. Parentheses subscript 2, and then the carbonate, CO3. The last one, FeSO4. This is a metal and a polyatomic anion. So sulfate is a 2 minus. That's just something that you would have memorized or known or seen. So if that's a 2 minus, the iron must have been a 2 plus, and I just give that Roman numeral 2. Okay, that's it for us today. Thanks, guys.